Welcome back. This video is going to cover the basics of Python's ability to read and write files, as well as to perform many of the common tasks that you could also use various command line tools to do, such as creating directories. To start, I'd like you to consider the question of what is a file? This may seem like an odd question, because of course you've used files before on your computer. In fact, when we write a Python program, we usually do so by creating a file. But what exactly is a file? Generally speaking, a file is simply a mechanism for shareable data that exists outside of a running program. This is normally an operating system feature, and more specifically, a file system feature. It's the file system that really defines what a file is, and what's particularly important is the metadata. That is, the data the file system stores about a file. For example, it's common that a file would have a name. It may also have access rights, or some ability to mark a file as read-only. The file system may also store the size of a file, or when the last time the file was written to. Files are sort of the operating system equivalent of program memory. When we work with files, we're transferring data in and out of program memory from into a file system. The open function is one of the few built-in functions of Python. Its general syntax is open, with the two inputs that are normally supplied, the file path and the mode, which defaults to R. The table shown here gives you a sense of what these various modes do. R, for example, opens the file for reading only. W opens it for reading, but if the file exists, it will truncate it, meaning that it'll start from scratch. If the file doesn't exist, it'll create it. Very similarly, X will also open, but will fail if the file already exists, and this will prevent overwriting a file. So it's essentially used for creating only. A is very commonly used, and that's used to append to a file. Next, you have two options, which can be used alongside these other four, for example, RB or WT. You have binary mode and text mode, and they indicate what they say. Binary mode means you're going to be reading and writing bytes. Text mode means you're going to be reading and writing characters, which do have a byte equivalent, but would be different numbers. Finally, in a triple string with RWXA followed by B or T, you can also include plus, which means you're going to be doing both reading and writing, although this is less commonly done. Two things to note. First, files have to be open prior to performing any operations. If a file is not open, you'll get an error. And then also files should be closed after completing operations. However, all files that are open will be closed after the Python interpreter is closed, or the program completes, which is essentially the same thing. Okay, let's jump over into JupyterLab and start working with files. The first thing I'm going to do is assign a new variable name to the result of open. I'm going to give a file a name called myfile.txt, and I'm going to open it for writing, which is going to create the file. Right after I do this, I'm going to f.close. So I'm opening a file for writing and then closing it. We see a file's created. If I open this in Jupyter, we can see nothing's in it, but I'll add some lines. Doing this manually. So this is creating a file, a blank file, very similar to running touch in the command line. Next, I will open a file for reading and print out the contents of it. So open file for reading and print the whole contents. Again, open the name of the file. This time I'm going to use the R mode, which stands for reading. I'm going to read a line of the file, or the contents. So I'll say contents is f.read. Read will read the entire contents up to the end and assign it to, in this case, a name called contents. Then I'll print contents, and again close the file. And you can see it prints both lines of the file in one print statement, meaning the entirety of this was printed. Okay, let's look at read with a number of characters. Again, I'm going to open myfile.txt for reading. But this time, I'll assign the first 10 characters, f.read10, and print first 10. We can see it seems to have read not 10 characters, but there's a character at the end here. 1, 2, 3, 4, 5 is the space, 6, 7, another space, 8, 9, and then another space here. Now you'll notice I didn't close the file. That's because I wanted to show what happens if I call read again. f.read 10. I'll say next 10. And I'll print next 10. We can see that you can read character by character. So if you call read without a number, you get the entirety of the file, or you can read at n characters at a time. Eventually, we're going to run out of characters. Let's see what happens. I'm going to simply run this line, these two lines over and over again. So now it looks like it's done. And you can see subsequent reads essentially return nothing. Let me close that file. Let's see what happens if a file is closed and we try to read. f.read 10. You can see we get an error. Again, a file needs to be open to read. Something that you're commonly going to use is to read a whole line from a file. Let's take a look at that. F equals open myfile.txt for reading. So it's open now, and I can write f.readline. You can see when I wrote f.readline, it read the string, and I want to point out that it includes new lines at the end. f.readline is going to read the next line. And you'll notice there's no new line at the end of this file, and that's because we didn't include one. So readline includes the new lines. Let me write f.close. And we'll write this again, this time in a loop. F equals open myfile.txt for reading. Now I'm going to write while true, L equals f.readline. But because I wrote while true, I need some way to close it. To close this, I'm going to detect when readline returns nothing. If L is equal to the empty string, break. Otherwise, print L. We can see that this ends when readline returns nothing. If we don't want those ugly lines in between, we can print out L.strip instead. And of course, I should be closing this file. F.close. You can see that now it doesn't print the new lines at the end because we stripped off the white space characters from that particular line of text. Now let's take a look at writing. This time I'm going to open myfile.txt for writing and run f.write a line of text and f.close. If I open up Jupyter, myfile.txt in Jupyter that was already open, looks like this didn't work. However, if I close it and open it back up again, we see that the actual contents of the file is what we wrote, and that it essentially removed the existing contents because W by default will overwrite the file. Let's look at what happens if we run this in append mode. A line of text and f.close. close, and open it again, and we can see that it appended those characters. We can also see that it didn't by default add a new line character in between. If we want to fix that, we need to put a new line character at the beginning. Open it up again, and we can see that now subsequent lines are being added with a new line in between. The last thing I want to talk about is the flush option, or at least the flush function. What this is used for is mostly where you have a file open for reading in one place and a file open for the same file open for writing in another place. To illustrate that, I'm going to create another notebook. In this notebook, I'm going to open myfile.txt, and I'm going to open it for reading. After I open it for reading, I'm going to write while true, print, or L equals f dot read line. If L is not equal to empty, then I'm going to print L. And I'm going to run this. Now you're going to notice that this is running continuously in the back. You're also going to notice that it read the existing contents. And it's seeming like it's done, but it's not actually done. This line is still running. I'm going to bring this notebook down here. Since I'm appending here, watch what happens when I write. We see that the next line of text is printed out. And just so you can see that that's indeed a new line of text, I'll change this to a new line of text. When I write over here, it gets read over here, because now readline is returning something. The reason flush is important is because this close operation is somewhat expensive. We don't necessarily want to open and close the file every time. Let's rewrite this a little bit differently. F equals open myfile.txt, and I'm going to open it again for appending. But this time I'm not going to do anything in close in this cell block. Now I'm going to write f.write \n another new line. Why didn't it print out another new line? That's because I didn't flush. When I flush, another new line gets printed. That's because it's somewhat expensive for the file system to continuously write text that gets written. And so what it tends to do is buffer it for a while and then write it when enough text has come in. You can force that writing with f.flush. Again, we should f.close. Over here, we have no way to stop this because we didn't include a stop, and so I'm going to stop it manually. And I'll close this. Okay. So you'll notice that we had to write that close often, and we kind of forgot it quite a bit. And so because this is fairly common, Python includes a special syntax known as the with statement. And what this will do is automatically open and close various resources, files being one of them, used by subsequent code. So instead of writing our code where we were constantly opening and then closing, we can write with open myfile.txt for appending, for example, and then as, so with whatever the open command is, as f. So it's kind of like writing f equals open instead of writing with open as f, and we might write something, f.write \n another line. We run this, Python will automatically close the file. We don't need to write that. And so I'll open this up, and we see we have all of our lines. If I run this again because we're appending, we will get another line added. So that's with. With should almost always be used when you're working with files. Rather than assigning the file to a name, you should write with open as f, or as whatever the name of the variable you would like. The last thing this video will cover is how to emulate various shell commands in Python. Many of these functions are available via the OS module. Import OS. Like the shell, our programs have a working directory which we can get, os.get wcwd. You'll see this print out in Windows path format. The backslashes are simply a single backslash when you use in Windows, but when you print out this in Python, you're going to see that it prints out with 2 backslashes because the backslash is an escape sequence that's used for a single backslash. We could also change the directory if we wanted to, os.chdir, and I'll change it to the previous directory and run os.getcwd to show that it changed. Let's change back, os.chdir. This time I have to use the name of the folder, sets and dictionaries. os.getcwd to illustrate that it changed. Something similar to ls is os.scan directory. In fact, there is a os.list directory if you want to list all the files, but I prefer os.scan directory because you can get more information from those. For example, this doesn't tell you if something is a folder or a file. You'll also notice that this listed a hidden file that's not being shown here, but it still is in the directory. os.scander gives you an iterator back that allows you to access a bunch of information about the file. And so let's iterate through that using a for loop. For dir entry in os.scan dir. And I'll print dir entry. It's not going to be interesting for right now, but we can see that we have 4 directory entries, 1 for each thing in the file. But what's inside here? Well, in order to figure that out, we need to look up some information for dir entry. But I can tell you that dir entry has a number of useful things inside it. For example, dir entry .name, or let's print dir entry not name. We'll give you the name of the file. We can print dir entry .path, and that'll give you the path of that file, and that's going to be relative to the scan dir. And so if we scanned ... and ran this, we would see all of these different files that are on my desktop. And you'll see that the path also changed for the dir entry.path. In general, if we write dir entry dot and hit tab, you can see we have the following available to us. We can check if something is a directory, if it's a file, if it's a symbolic link, which is like a shortcut in Windows. We've seen the name and the path, and then we also have a function called stat. And I need to print it in order to see what that is. Stat returns a whole big structure, stat result, that has a lot of other information about the file. For example, it has its size in there. It also has various things in terms of when the last time it was created, when the last time it was modified. And so if you need that information or you need to access that, you can store it in a variable, stats, and then print out that specific thing. Let's print out stats.size, st-size. And you can see the sizes of the various files in my previous working directory, or we can print it out with the, let's get it at the name of the file as well. So f equals dir entry.path. And we'll print out f and that. And so that's printing out the file name and the size of that file. We also have the ability to make directories. So let's make a directory with os.makeDirs. So os.makeDirs. And I'm going to go into contextual help so you can see some information on os.makeDirs. And you can see that you can provide a name, you can provide a file mode. If this were Unix, that would be relevant. And then we can say if whether or not it exists, it's okay to create it. So makeDirs, let's say make a directory called temporary. That'll make it in my current directory, and you'll see that a directory gets created. All right. We can also rename. So let's rename that directory we just created, os.rename, and I'm going to rename temporary to temp. and you can see that the name changes. This can also be used for moving, just like the move command in the command line can be used for renaming. I'm going to close the contextual help for the moment. Next one would be remove, so os.remove, and I'll remove this other Python file that we have opened, untitled 1.ipynb, and you can see it deletes it. And then lastly, let's show how I can remove a directory, rmdir, and I'll write temp, and that directory gets removed. All right, last thing I wanted to mention, because I use it quite often, is the glob or globe module. Import globe. And that's because this can be used for pattern matching. And so if I write glob or globe.globe and put star.txt, you can see that it'll print out everything that ends in .txt. And so if I were to create another file, for example, I'll say new file here, anything.txt, and run this again, we'll get a list of both of those. And so glob is actually a pretty nice thing to be able to use pattern matching to find all of a specific type of file. And we can use question marks if we want to. For example, we can write question mark file.txt, and that'll find my file.txt. So that is a wildcard for a single one, or we can use the star and that would work as well. All right, so in summary, what we've talked about today is reading and writing files, which have to be opened first. This is extremely low level though. When we're working with known formats, there's likely going to be a specialized library that allows you to follow that format exactly. You can also use Python similarly to the shell by using the OS module and the related globe module. In fact, the Python interpreter is very similar to the shell interpreter. However, if your goal is to only manipulate files and folders, a shell script is usually recommended because more people will understand what that means.